So we're going to start with trigonometry. We start with chapter 2. Now trigonometry has lots of vocabulary that you have to use in your answers. So maybe keep a sheet of vocabulary or cue cards of vocabulary, because you're going to need to know these words in order to get marks for your work. Okay, so you're going to need to know the actual words, not just show your work in this case. So first, our first word would be supplementary angles. Two angles are considered supplementary if they add up to 180 degrees. Okay, so if we look at the first example, we have 60 and 120, and 60 degrees plus 120 degrees equals 180 degrees. So yes, those two angles are supplementary. If I told you that this angle was 115 degrees, and what kind of angle is this? Since it's a big wide angle, hopefully you said an obtuse angle. And the other angle is 65 degrees. Let's see. 115 plus degrees plus 60 degrees equals 180 degrees. Yep, supplementary. And then our last one, if you look, this makes a perpendicular or a right angle. So two right angles are 90 degrees. 90 degrees plus 90 degrees equal 180 degrees. So also supplementary. Now what do you notice about these last two examples? And I'll draw what they have in common. They're both on that straight line, right? And when angles are on a straight line, they have to equal 180 degrees. Because if we think, here's our straight line. Let's draw a little half circle on there, and we'll complete the circle. So a circle has 360 degrees in it, and half a circle has, so half the circle will have 180 degrees. And half the circle is denoted by this line. So whenever you see a line with angles on it, no matter how many angles, those angles have to equal to 180 degrees. So here we have examples with two angles, but you may have examples with 2 or 3 or more angles. So our first word was supplementary. Our second word is transversal. And a transversal is a line that intersects 2 or more lines. Okay, so this red line here is a transversal. That's all it is. If you have a line that goes through 2 other lines, or 3 other lines, or 4 other lines, it's called a transversal. Then we have lines that are parallel. So these are lines that run beside each other. They're the same distance apart. They'll never touch. So think of railroad tracks. Okay, so railroad tracks, if they're laid in a straight line, will never touch each other. And they will always be the same distance apart because they have to be for the train to run on it. So that's the best example in the real world of parallel lines. And for abbreviating, for denoting parallel lines, of course there is a symbol in math, and it's 2 straight lines. Okay, so the example A is parallel to CD. So on a diagram, we also have another symbol here. So if you see symbols like this, it shows that those lines are parallel. So if we draw some lines, and of course mine are not exactly parallel, but imagine. And we can even draw 2 more lines. I'll call that E, F, and G, H. Okay, because of these little triangle marks, okay, and sorry, that makes it, they're not inequality lines, okay, they're just little arrows. We can see that AB, so line AB is parallel to line CD. And then because those both have 1 mark. And if you'll look, E and F and G and H both have 2 little arrows. And so those are parallel to each other. And so the reason why A and B and C and D have just 1 and E and F and G and H have 2 is just to denote the fact that A and B is parallel to C and D, but not to E and F and G and H. Okay, so it's just to show that those 2 belong together and the 2 vertical lines belong together. So now we're going to get into some of the really good where it's in geometry, or in trigonometry. So when a transversal intersects a pair of parallel lines, like this, here's my transversal, I've intersected both lines, there are relationships between these angles. So let's label the angles and go through the relationships. So, first relationship, alternate interior angles are equal. So when we say alternate interior, we mean basically opposite inside angles. Okay, alternate interior is the official way to say it, but that's what they're implying. And so basically we just have to make a Z shape using our parallel lines and our transversal. And if we refer back to our original diagram, this would be C and F. So these are interior, right? They're inside the two parallel lines, and they're opposite each other, so they equal each other. And then we have the other alternate interior angles. So we'll draw our backwards stretched out Z, and we have D and E. So D equals E. Okay, so alternate interior angles are equal, and alternate exterior angles are equal. So these would be opposite outside angles. So if we have our parallel lines, we're going to go on the outside of them. So we have A, and then on the other outside, opposite A would be H. And A will equal H. And then we'll do the other, which are B and G. And because B and G are alternate exterior angles, they are equal to each other. So anytime you see, and remember that these are our parallel lines, okay, all of these, we're working back with this original line. So they have to be parallel. But if you have two parallel lines intersected by a transversal, these rules will always apply. So we have alternate interior, alternate exterior, and then we have corresponding angles. So basically, if we go on, this is the interior and the exterior angle on one side of the transversal. So if we look at our transversal, let's look at the left first. So we'll do the outside angle, A, and the inside angle, E. And those equal each other. And you'll see that they make an F shape. So it's an upside down slanty F, but it's an F. So that's on the right side, the left side of the transversal. Let's look at the other set on the left side of the transversal. So again, we want to make our F, and since we did A as the outside, we'll do this outside, so G, and the inside of C. Okay, you'll see there's your F again. So C equals G. And then let's do the right side of the transversal. So there's my transversal. I need an outside and an inside angle. So let's do our outside angle and our inside angle, and those equal each other. And then again on the right side of the transversal, our outside angle will be H because it's outside the parallel lines, and our inside angle will be D because it's inside the parallel lines. Okay, so that is corresponding angles are equal. Then we have vertical angles are equal. And when we talk about vertical angles, we just mean the ones that are directly opposite each other. So if I start with A, the angle that's opposite from A is D. So A equals D. And then my other set is E and F. So E equals F. Okay. Of course, there is, so those are the ones that are running left to right, but we can go from right to left too. So we have B and C are equal because they are vertical angles. And then we have F and G. And sorry, this should have been H. So F equals G. Okay. And then we have one last rule. Consecutive interior angles are supplementary. So this means they add up to 180 degrees. So this means that angles that are on the inside of the parallel lines on the same side of the transverse. So here's my transversal. If we look on the left side, we want to be inside our parallel lines. So those are our two angles, C and E. And we'll know that C plus E equals 180 degrees. Okay, then if we go on the right side of our transversal, inside the parallel lines, we have D and F, and this will also equal 180 degrees. Okay, so let's go back up and summarize on our original diagram here. So let's write a summary. Okay, so we know that what? If we look at vertical angles are equal, we know that A equals D and B equals C. Okay, and we also know that, what else do we know? We know that C plus E, sorry, not 8, E, C plus E will equal 180 degrees. We know that D plus F will equal 180 degrees. We know that because D and E are alternate interior angles, they equal each other. So that means E also equals A. And then E and F, E and H are vertical angles, so they equal each other. So we know that because of alternate exterior angles, B equals G. And we know that because of vertical angles are equal, G equals F. Okay. And there are all different combinations that we can go through and say about these things because of these rules. So again, it seems like a lot of rules, and it is, but just practice it. Okay, just practice them and make sure you do the worksheet and the practice problems, and together we will do an example here. Okay, so we'll draw in our parallel lines, okay, because we're told that lines A and B and C and D are parallel. And we have a transversal EF intersecting them. So let's find all the missing angles. And we will be given this angle here, 130 degrees. So if we are given that angle EGB equals 130 degrees. And the way you name angles is, so the angle in the middle, so here we have EGB, okay? So this angle here we would name AGF, okay? Or this angle here would be CHF. Okay, so always couch it in terms of three angles, or sorry, three letters. The angle in the middle will be where the angle you're looking for actually lies. And then the two letters on the outside will just denote the beginning and end point to draw that angle. So if we know that angle EGB equals 130 degrees, what else do we know? What other angle equals that? Okay, so hopefully you can say a whole bunch of things. Let's go with AGH here. AGH. So this is 130 degrees. What else is 130 degrees? Okay, so hopefully one of the ones you thought of was 130 degrees. Or sorry, was that one over here? So CHF equals 130 degrees. Okay, and just 1 second. Okay, so I want you to try to go through, I've erased some of it, you can see. I want you to go through and see which ones you can get by yourself. Okay, work very slowly. Just get the most obvious ones you can, and then come back and check with the answers, because I'll go through and I'll put them all down, all right? Okay, so let's go through this. So we have angle EGB equals 130 degrees. And this will also equal angle GHD. So if we do down there. Okay, and if you did this in a different order, that's fine. And what are these two angles? These are corresponding angles. Okay. Then, since we know that EGB equals 130 degrees, we also know that this will equal 130 degrees, angle CHF. And that's because if we look at this angle and this angle, these are alternate exterior angles. Okay, we can look at angle AGE. So AGE, this angle right here. And because these are on a line, these will be what we call supplementary angles. So we'll know that they have to equal to 180 degrees, and that makes this 50 degrees. And so if we look down here, AGE, this is a supplementary angle. Okay, and we say 180 minus 130 equals 50 degrees. Symbol here stands for angle. Okay, that's why I've written here angle EGB, angle AGE. Okay, if we look at angle AGE, because it's 50 degrees, angle CHG, so CHG, this one here, is also 50 degrees, because these are corresponding angles. Likewise, if CHG is 50 degrees, HGB, so HGB right here is 50 degrees. And that is because if we look at these two angles, so CHG and HGB, these are alternate interior angles. So they make a Z. And then FHD and CHD, so look for FHD right here, that's 50 degrees. And there we can say those are vertical angles. So if you got those a different way or you had different reasons, that's fine. There are other reasons that you could have used. You could have used consecutive interior angles. You could have used different corresponding angles, alternate exterior angles. Again, go through this and just try to prove it all the different ways you can so that you can get familiar with saying things like alternate exterior, corresponding, etc., etc. And then lastly, we can use angles to test for parallel lines. So in this case, you could be given the angles and asked, are these lines parallel? How do you know? Okay, so if a transversal intersects two lines, the lines are parallel if corresponding angles are equal, alternate interior angles are equal, alternate exterior angles are equal, and consecutive interior angles are supplementary. You do not need all of these, but you need to prove at least one. So let's do these ones together. So we want to know, are these lines parallel? So if we're given that this is 60 degrees and this is 60 degrees, are these two lines parallel? Hopefully you said yes. So these angles are what? They are corresponding angles. That are equal. So this is parallel lines. Then we have, if we look here, we have 93 degrees, and this is 85 degrees. So remember that these would be called consecutive interior angles. They have to equal 180 degrees. So let's see, 93 degrees plus 85 degrees equals 178 degrees. Okay, so 178 does not equal 180 degrees. And consecutive interior angles must equal 180 degrees. Therefore, not parallel. Okay, so this one is not parallel. And last, this is 80 degrees, and this is 82 degrees. Now our parallel lines, or our supposed parallel lines, have just been flipped to the vertical, and our transversal is going through horizontally, but the rules are still the same. So these would be considered what? Alternate exterior angles. And alternate exterior angles must be equal in order for the lines to be parallel. And 80 degrees does not equal 82 degrees. So therefore, these are not parallel. So there's some questions in the book here. Go through them. Again, just practice using these terminologies, and there will be one more video for spring break. Okay, so be sure to watch one more video for this lesson.